Hey everyone! Welcome back to our channel. If you're passionate about technology and how it shapes our world, then you're in the right place. Today, we're diving into a fascinating topic in the realm of artificial intelligence, model agnosticism in AI interpretability. Now, that might sound a bit technical, but don't worry. We're going to break it down in a way that's easy to understand. So, let's jump right in. Before we get started, let me ask you this. Have you ever wondered how AI systems make decisions? Whether it's a recommendation for a movie you might like on Netflix or a crucial medical diagnosis, understanding how these models come to their conclusions is essential. But what if I told you there's a way to interpret these models, regardless of their architecture? That's where model agnosticism comes into play. Alright, let's unpack this. First off, what exactly is model agnosticism? In the context of AI interpretability, model agnosticism refers to the ability to apply interpretability techniques to any machine learning model, regardless of its complexity or structure. Whether it's a simple linear regression or a complex deep learning model, model-agnostic methods allow researchers and practitioners to gain insights into how these models function. Imagine you have two different models, a decision tree and a neural network. A decision tree is relatively straightforward. You can visualize it and see how decisions are made. A neural network, on the other hand, is often seen as a black box. It's more challenging to understand how it arrives at its conclusions. This is where model-agnostic methods shine. One popular model-agnostic technique is called LIME, which stands for Local Interpretable Model-Agnostic Explanations. LIME works by approximating the complex model with a simpler one in the vicinity of the prediction. Let's say you have a complicated black box model predicting whether an email is spam or not. LIME will take a specific email that was classified as spam and create a simpler model using that email's features and a few similar examples. By doing this, LIME helps you understand which features contributed most to the model's decision. For instance, it might reveal that specific keywords like free or a limited offer were the major contributors to the spam classification. This insight can be invaluable for improving the model and for understanding the underlying patterns in the data. Another noteworthy method is SHAP, short for S-happily additive explanations. SHAP values are grounded in cooperative game theory and provide a way to quantify the contribution of each feature to a particular prediction. Let's say we're using a neural network to predict house prices based on various features like square footage, location, and number of bedrooms. SHAP values will tell us how much each of these features contributed to the final price prediction for a specific house. For example, you might find that location contributed positively, while the number of bedrooms had a negligible effect. This level of detail helps homeowners, real estate agents, and developers make informed decisions based on the model's outputs. Now, you might be wondering, why is model agnosticism important? Well, in an age where AI is becoming more integrated into our daily lives, transparency is crucial. Users want to understand how decisions are made, especially in sensitive areas like healthcare or finance. By employing model-agnostic methods, we can build trust in AI systems. Additionally, model agnosticism enables researchers to evaluate and compare different algorithms' interpretability without getting bogged down in the specifics of each model. This flexibility can lead to better model design and, ultimately, improved AI systems. Let's take a practical example. Consider a healthcare scenario where an AI model predicts patient outcomes based on a variety of medical features. A model-agnostic approach can help doctors understand which factors are most critical in determining a patient's prognosis. This transparency not only helps in validating the model's predictions but also aids in clinical decision-making by allowing healthcare professionals to rely on the model's insights. In summary, model agnosticism in AI interpretability is a powerful concept that allows us to understand and trust complex models, regardless of their structure. Techniques like LIME and SHAP provide invaluable insights into how models make decisions, promoting transparency and accountability in AI applications. So, whether you're a data scientist, a business professional, or simply an AI enthusiast, embracing model agnosticism can help you better navigate the exciting world of artificial intelligence. If you found this video helpful, Please give it a thumbs up and subscribe for more content on AI and technology. Have any questions or topics you'd like us to cover? Drop them in the comments below. Thanks for watching, and see you next time.